YouTube at my PC, and today I've got a prop with me for our tutorial. In today's tutorial we're going to talk about arrays, and I'm going to demonstrate it using this thing. So I made a tutorial in GameMaker about arrays, and I used the bookcase example, and I figured since I'm filming myself in real life now, I might as well use an actual bookcase, or in this case, close enough. So what an array is, it's a combination of several variables. So we're going to use a bookcase as an example, and we're going to assign a variable to each one of these shelves. So let's say for this first shelf, we're going to call the variable shelf1. And it doesn't really matter what type, we can make it a byte or yeah, we'll make it a byte. We'll call it byte shelf1. And it's going to equal the amount of DVDs or discs I have on the row. So in this case, byte shelf1 is going to equal 1, 2, 3, 4, 5, 6, 7. Alright? And then we'll go with the same process with the second shelf. So the second shelf is byte shelf2, and byte shelf2 equals 10. Third one, byte shelf3 equals byte shelf3 equals 9. Byte shelf4 equals 7. So we have 4 variables here: shelf1, shelf2, shelf3, shelf4. And what we're gonna do is instead of having 4 variables, we're gonna create one array. And the way an array works is naming just a little different variables. So this one will be called, we'll change it to, in order to make an array, we'll change it to shelf open bracket 0 close bracket, shelf open bracket 1 close bracket, shelf open bracket 2 close bracket, shelf open bracket 3 close bracket. And the use of this is we can plug in variables in the brackets to find which shelf. So we're going to create a variable called index, and we're going to say index equals 1. So remember, this one was shelf 0, 1, 2, 3, and if index equals 1, we try to find shelf open bracket index close bracket. That will give us this shelf because index equals 1 and this is shelf 1. So shelf index will give us 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how it works. If you say, give me the 0th index of the shelf array, that'll give us this one, and it will give us 1, 2, 3, 4, 5, 6, 7. So that's the 0th index. Then if we say the second index of the array, that's so 0, 1, 2. This is the second index of the array, and that equals 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is the concept behind arrays. I hope you guys understood it. If you don't understand now, hopefully you understand by the end of this tutorial. So here it comes.
So let's get started with the tutorial. I've already made the main method and the class to go ahead and save time. So to get started, I'm going to create a new variable called byte index and set equal to byte dot parse byte args 0. So this will be equal to the first thing we input after our command, and you should be pretty familiar with that already. Okay, and now we're going to go ahead and create our array. We're going to call it shelf. So we're going to start off. This is very similar to creating primitive data types. So I'm going to call it byte shelf to start out with. And the only difference is these brackets. These brackets indicate that it's an array. And specifically a single dimension array because it's only one set of brackets. If you had more sets of brackets, it'll indicate there's more dimensions to the array. So that's 2-dimensional, 3-dimensional, 4-dimensional, etc., etc., etc. You don't have to know what multi-dimensional arrays are, just know of them. Today we're just going to talk about single-dimensional arrays. Another thing that's about the brackets is that it doesn't matter where you put them, so they can go either after byte or they can go after shelf. The same concept applies up here in the main method with the string args argument. It doesn't matter if we put that after the args or if we put that after the string. It makes no difference whatsoever. Okay, so now we set equal to. I'm going to set equal to new byte brackets and 4. So this is a new operator. I haven't used it at all in any of my tutorials yet. And what it basically is it's used whenever you create a new variable. Technically it can be used when you're creating primitive data types, but it really becomes necessary now when we start creating things with settings such as, like, here they got the 4. So when you start working with constructor methods and settings and that kind of stuff, the new variable becomes necessary, and you'll see that you're going to use it almost always whenever you're creating something, creating a new object or variable. So then comes this part. Generally, as a general rule for this part, when you're defining what it is, this matches the type pretty much always, and then what comes after that are the settings. So we have 4 in there. That indicates that our array is going to have 4 spots in it. There's going to be a length of 4. There's going to be 4 variables inside the array. So if I were to put this in a sentence, it would say create a byte array that's called shelf, and set it equal to a new byte array with 4 spots in it. Okay, so now we're going to set each individual spot in the array equal to a number, depending on how many books there are in that shelf, or how many DVDs in our case. So I'll go ahead and start with the first one. So shelf 0, which is the very first index in that array, and I'm going to set equal to 7 because that's how many books there are on that first shelf. So I'm setting this part of the array equal to 7. And next is shelf 1, set equal to 10. Next is shelf 2, set equal to 9. And next is shelf 3, and set that equal to 7 again. So now we've created our array. We've created a different number for each of the individual indices in each individual index, and that's how it works. One thing I want to talk about before we move on is that arrays are very rigid in how long they are. So we set this equal to 4, and we just create 1 for each of the 4 spots. And if we were to try and create a 5th spot, we'd get an error because we said the length was 4 and it has to stay at 4. And if we were to only, let's say we were to take out this last one, and if we were to try and find this spot, since we didn't define it, we'll get an error because it's undefined, because this doesn't define the individual spots, it just says they exist, basically. Another thing I want to talk about is that this is 0 based. So it says 4 spots, but we don't have an index for 4, because when it says 4, it's saying 0, 1, 2, 3, 4. That's 4 spots, which with 0 based, everything's subtracted by 1, and I just want you to understand that. That's the reason why that's not a 4th spot. There are 4 indexes, but there's not a 4th index because 0 is included as an index, and that just makes everything all confusing. But you just are better off getting used to 0 based systems because it's used a lot in programming. So now we've had the user input the index, and then we want to print out, when you use the index, check the index in the array, what you get. So I'm typing on system.out.println, and I'm going to say shelf index. This is where a lot of people get confused. So if the user sets index equal to 2, okay, then this will look up the second index in shelf, which we can look right here is equal to 9. So this will be 9 if index is equal to 2. If the user inputs 0 for index, it'll look up the 0th index in shelf, which is equal to 7. So this will print out 7. So now I'll go ahead and save it, and I'll go ahead and compile it. So javac arrays.java. No errors. Fine. Awesome. Okay, and I'll run it. Java arrays. And of course, I have to put in the argument because I talked about that. So I'm going to type down 1. It gives me 10 because 10 was the number we put down for the first index in for the index 1 in the shelf array. So now let's try it with 3. 7. And you see if I go too high, it'll say index out of bounds. You'll probably come across this fairly often when working with arrays. So just know that array index out of bounds exception, that's what occurs whenever you choose a number that's too big and defined. And let's see, what we didn't do is 2. 2 is 9, that's right. So that's all for our tutorial about arrays. If you want to see how well you understand it, go ahead and try the challenge. So for this challenge, it's going to be a little bit lazy. I'm going to reuse one of my older challenges. This is going to be the same challenge I used in my basic logic one, only this time you only need to input a number in order to get what the ID represents. In case you don't remember it, this is just going to be used for when you want to look up Minecraft IDs when you want to spawn items in Minecraft. Each number can be represented by an ID. So let's say you wanted to find the ID for 5. So type it on Java arrays. See, that's just why I named it. And 5, and tell you that's the ID for wooden planks. And then I could do 10 and lava. So this is a lot easier with arrays than it is with logic operations. But yeah, so it's a lot more efficient this way. I'd say it probably takes about 2 to 3 times as much code to do it the other way than it does this way. And and it's easier to modify it this way as well. That said, I did use different method for this. The goal of this tutorial was to teach you the concepts behind arrays, but I didn't tell you all the ways that you can create arrays, because there's like probably 3 or 4 ways that you can create arrays. I just showed you the most generic one, the one that will probably help you most. But there's one that can be done with less space, and as a part of the challenge, I recommend that you look up a more efficient way of doing this. Because like for this one, I did over 30 different items in here, and it took probably less time. Oh, I didn't do 58, but you get the point. So good luck. Anyway, so that's the end of the tutorial. I hope you guys found it helpful. If you found this challenge helpful, I also have a website that contains more challenges. So go head over to that website. It also contains my games and a list of my game maker tutorials, and it'll contain my Java tutorials as well in the near future. Yeah, so please rate and comment to support my videos, and if you want to see more, subscribe, and I'll see you guys next time.